Hi everyone, in this video we are going to discuss how our planet and all these nations responded to that smoking gun graph. If you recall, the smoking gun graph simply showed that as the concentration of ozone decreased, our concentration of stratospheric chlorine directly increased. So they were completely, almost beautifully, inversely proportional. So what happened? How did our planet respond once we got this information? Well, it started off in 1977, where a group of people came together, and this is the UNEP. Okay, so now UNEP is the United Nations Environmental Program. Now they spell program kind of funny, but we have to do it. It's okay. Program, double M with an E. All right, United Nations Environmental Program. They got together and they created the World Plan of Action. So the world, right? This is for everybody in the world, of the ozone layer. Okay, so here they came together, they came up with a plan, and essentially what they did is they started to begin setting guidelines. So here is what we do from here on forward. Here's how we stop the production of CFCs, and here's how we protect our planet. So then in 1978, the US and Canada stepped up, so go us. They stepped up and they banned CFC use in spray cans, so those aerosol cans. And so what used to happen is they would put these CFCs in spray cans, so like paint cans, or anytime you're doing like vandalism, I guess that's what I think of. You're not only ruining a mural, but you're also ruining our planet, so don't vandalize anyway. But they basically banned these CFC chemicals inside the spray cans, which was huge. So that was really, really good for both us and Canada. All right, so then we had to jump forward just a little bit of time before we kind of came together again. It was 1985, and we had this Vienna Convention. Now, the Vienna Convention, they came together and their topic was on the protection of the ozone layer. Good topic, right? Now, here's what happened. Everybody that was there signed a treaty, but not everyone attended this convention, unfortunately. But they signed a treaty essentially saying they were going to move forward. They were going to abide by these guidelines set forth, and they were going to do whatever they can to halt the production of CFCs and protect our planet. They need to protect that ozone layer. They cannot make that ozone hole any bigger. But it wasn't until 1987 when the big thing happened. And this is the big one. This is the most important one. We had the Montreal Protocol. Now, this is long, but I'm going to give you the whole name, so I want to make sure you know it. So it's Montreal Protocol on substances that deplete the ozone layer. Okay? That was the Montreal Protocol. Here was the most important thing, okay? They signed a treaty, again, so it was a treaty, but the treaty, this time, unlike the one in 85, actually had a timetable. So instead of saying, here's some guidelines, here's some advice, here's what we think you should do, this is a timetable. Here's your treaty. You must do everything that we have listed, but most importantly, everybody that signed it actually had to ratify it. Okay, so this was huge. They had to ratify their treaty, which was awesome. And actually what happened, up in 2009, so it took a while, like a really long time, but in 2009, every single United Nations member that signed their treaty had ratified it. So yay for every United Nations members. Now, let's come together and look at how that affects our global production of our CFCs. So here's our graph. On the x-axis down here, we see our years. Okay, so it starts at 1950, goes all the way to about year 2000. And then on our y-axis right here, we have thousands of tons. Okay, so right here when it says 200 tons produced, it's actually 200,000 tons produced. So make sure we get our axes correct in our units. So what we see here, this is global CFC production. So in 1950s, when we're only using from refrigerators, they were pretty small. We weren't creating that much. Then we started to increase in 1960s. This is when we started using them in air conditioning units, getting higher. We started using them in spray cans. Up until this point right here where the US and Canada said, all right, enough. We are no longer using these in spray cans. So we actually see quite a little bit of a dip, not huge, but a dip. And so the production gets a little bit lower, and then bam. this is where it was really bad. And so in industry, so chemical industry, they realized that CFCs could be used as solvents, and it was very advantageous because they're non-toxic, they're not flammable. It was very advantageous for them to use these as solvents in their industrial processes. Problem was, that means we seriously started creating a lot more CFCs. Up until this point of 1987, when we all signed that Montreal Protocol. So before I continue on, right here at this point, at the peak, how many tons of CFCs globally were being produced? Okay, how many tons of CFCs globally were being produced? And so I want to clean this graph up for you so you don't have anything that's messing or confusing for you. Okay, answer the question. Good luck. All right, did you get an answer? Hopefully you did. So what you needed to do was go to this point right here, come all the way across in the graph, and kind of decide what number that is. And so there's a little wiggle room. I probably would have said it was 1250, except for the fact that's in thousands of tons, so it's really 1,250,000 tons. Okay, so a lot of tons of CFCs were being produced at its peak. Luckily, when we shoot forward to 1992, it was significantly lower, down to about 500,000 tons, and even now in current time it's much lower. In fact, most places don't produce CFCs, at least not legally, but we still have some problems. We're going to get to that in just a second. But now, how did this affect our stratospheric concentration of chlorine? So let's draw a little graph here. So on this side, we're going to say it's our concentration of chlorine in the stratosphere. Okay, so I'm just talking about the stratosphere. And at the bottom, we're going to do some years again. So we'll start here at maybe 1950. We're going to go all the way to about 2000, even to, 2000, and then even to about right now, 2015. So in the 1950s, our stratospheric concentration was pretty low, started off like this, got a little bit higher, and in 2000, that's when it peaked. So basically what we see is that we have a 10-year lapse. So when we had a huge amount of production of CFCs in the 1990s, we only actually saw the result of that in our stratosphere in terms of chlorine concentration 10 years later in 2000. So we peaked right here at 2000, and thankfully it significantly dropped, not nearly that much, but it significantly dropped, and we're getting lower and lower. But just so you have a point of it right now, we are at about 3,500 parts per trillion of our chlorine concentration in the atmosphere at about 2000, and right now in 2015 we're at about 2,700 or so. It's kind of hard to get a real number on it because we're talking about how many different molecules were produced and the result of it, but from what I could find, it was around 2,700 parts per trillion. So still a lot. We're nowhere near where we need to be, but we are significantly better than we were 15 years ago in 2000. So we're at least moving in the right direction. So here are the things. We have some problems, guys. 3 major problems from our CFC production, and still things that we have not been able to fix or that we're still working toward. So number 1, we need to find a way to get funds to developing nations. It is very, very difficult for them to have air conditioners that use things other than CFCs, or find a way to create a whole new production line or maybe a whole new plant that makes a whole new molecule that can help them out to replace CFCs. It's not very easy to just say, okay, we're no longer going to use this plant anymore, we're no longer going to use these molecules. That costs money, and a lot of money, and you have to design a whole new plant, you have to design all new things, you have to get new employees, or maybe you can keep the same employees, but you have to train them again. So this costs so much money to do this, so we need to help out our developing nations. Number 2, okay, we need to find a way to police illegal CFC trade. So this actually happens. People are out there in the black market trading CFCs because you're not allowed to produce them anymore, mostly. And so there are people out there trading them, and so our CFCs are still out in the environment. They're still going up in the atmosphere. We haven't just wiped them all out and they're all gone. They're still here. So we need to find a way to penalize people, or kind of like hunt them down, have a sting operation and be like, hey, you're trading CFCs, and grab them from there. And so we have to kind of find a way to do this, which seems silly because it's a chemical, but it is something that we have to do. All right, and then the last thing we need to do, and we're going to come back to this, is that we need to start phasing out CFC replacements. And so what happened is, after we said, okay, we can no longer make CFCs, people had to find something else to make. Well, they did. They found tons of different options. We'll do a whole video on that in just a second. But the thing is, these CFC replacements, most of them are greenhouse gases. So we fix one problem and create a giant other one. So this is a bad news. And this, we have a whole unit on this, this will be unit 3, but we have to just kind of find another way. So we still have some problems. We're definitely moving forward. We're in a much better place than we were in the 1990s, definitely better than we were in the 2000, but we're not there yet. Take care of yourself, guys.